Aptos Blockchain. Wow, I never thought I was going to say this. Finally, I can deploy a decentralized application without the need of having browser wallets connected. It's huge. If I don't need to worry about the aspect of having a browser wallet and making sure that I have proper security in that browser session, I have certificates, and I have a completely encrypted session between the end user and the blockchain, then that is a heavy lift that has been taken out of my shoulders as a developer. Not only that, I am eliminating third-party security aspect of a browser wallet, which is not in our control. There's a security issue in a third-party wallet that's not in our control, which is also something that I'm going to be removing out of my responsibility as a developer. We are building an application that is going to be more user-friendly. But one thing that we have to dominate in order for us to build decentralized applications in the Aptos blockchain, we have to learn how to write Move. There's a language called Move, which we have to write the smart contract so then we can deploy our decentralized application in the Aptos blockchain. So don't worry, this is what I'm here for. I built a tutorial. It's going to be a very, very, very interesting tutorial in which we will write our Move smart contract, and I guarantee you that you will become more familiar, comfortable, that you can continue the journey developing Move smart contract. So you can finally deploy a keyless decentralized application. Enough with the talking. We have to move so then we can learn Move. I know that was a lame joke. I tried my best. Let's go. When we initiate a Move smart contract, we are going to define this to be a module. A module is a smart contract. That's it. Here's the clever thing about a Move smart contract. I'm going to say quite smart is the way that we assign an address to that smart contract, or the way that we identify the smart contract in the blockchain, in the Aptos blockchain, is with the address of the deployer wallet, or the owner wallet, the wallet that was used to deploy the smart contract. Different from what we see in other blockchains, for example, in EVM-based blockchains, we will generate a completely different contract address. When we deploy the smart contract, we will obtain a smart contract address. In the case of Aptos, it's not like that. The address of the smart contract, listen to me carefully, the address of the smart contract is the address of the owner wallet, aka the wallet that deployed the smart contract. And you might ask yourself, if that's the case, what if I deploy multiple smart contracts using the same wallet? That is not a problem. When we define a module, we then specify a variable that points to that owner wallet. This will be the account address. The owner address is the reference to the wallet that was used to deploy the smart contract. After that, we will then specify that a contract name has been deployed under this owner wallet or owner address. So that's how we can identify, or that's how we can send calls into that Move smart contract. Because when I use the Aptos SDK, I am going to be defining the transaction pointing to the owner address of the wallet that was used to deploy the smart contract, then specifying the name of the contract. So I can have multiple contracts. Let's say I deployed a token smart contract, net2dev coin. I could also deploy a staking smart contract that is also derived from the same wallet that deployed the token smart contract. Not only that, I can also deploy some form of DeFi swap interface under the same wallet. So that owner wallet has 3 different smart contracts deployed. They will all point to the same owner wallet, the same owner wallet address. Then we will just invoke the name of the contract, and that's how we get to the contract. It's pretty clever. Instead of me having 3 different contract addresses, I only have one address referenced to the name of the contract that is deployed under that owner wallet or account. Let's continue. Now that we know when we deploy a module, we are deploying a smart contract, we are going to be pointing the owner address, then the name of the smart contract. And we start writing the contract. The first thing that I'm going to do, I am going to be importing some libraries that I need to use in this Move module. I am going to be typing use std as in standard. Then I will be invoking the name of the function or the import that I need to be interacting with in this module, in the smart contract. Let's say I want to interact with another smart contract or another module. What I can do is what? I can type use the wallet that was used to deploy the contract, in this case, the owner address, and then the contract name. And that's how I can import different modules so that I can invoke other functions present on those external contracts or those contracts that I need to be interacting with. Now let's go ahead and define some constants. When we define a constant in the global scope of the contract, we can use those values across my functions to do anything. For example, when we define a constant in a move module, we are defining a value that will be in the global scope of the contract, and I can use across all my functions to do any type of operation or interaction. For example, I can define a constant that will be used to generate error log messages. Let's say I am going to be validating or asserting a function call and making sure that XYZ parameter is provided by the signer when it does the call to the function. And in case the signer doesn't provide the right values, I can stop the function from executing. I can provide an error log message with a code value that will tell me when the transaction failed and what was the reason behind that transaction failure. So in my case, I am going to type constant. We are defining this E as an error not correct. So what we are going to do, in case a function, the user didn't provide the right parameters and we validated or we verify those values provided by the user and we realize that those values are not correct, we are going to be generating an error log message during the transaction execution that says not correct. And the error code will be 1. That will tell us exactly where the issue during that execution failed. What was the issue behind that execution failure? And we are going to be defining this constant to be unsigned integer 64. So we type E, error, not correct, colon, U64 equals 1. The error code is 1. Simple. Now let's write a sample function in a move module. There's different types of functions in a move smart contract. When we define a function to be public function, that means that function, I can access that outside using, for example, the SDK. I can call that function in the blockchain, but I'm not going to be able to provide external arguments, which means I can, let's say, call a function that the only information that I will be able to provide is going to be the signer that it is interacting with that function, but nothing else. I am not going to be able to provide, let's say, strings, numbers, integers, etc., because the function type is public but doesn't allow arguments to be provided or external arguments to be input into that function call. When the signer interacts with that function, that argument can be automatically provided. That is not an argument that will be inserted in that transaction envelope using the SDK. But let's say we do need to provide arguments, then we will type public entry. When we define the function to be entry, then we can provide external arguments. We can provide string values, we can provide integers, any type of argument that has been defined as required in the function arguments. So we type public entry fun, that will be an external function that can be called using the SDK, and we can provide arguments during that execution. An example, I can provide now U64 an ID. I can provide an integer that will be classified as type U64. And we have another public function that can be defined as friend. What is friend? A friend is someone that you trust, right? Well, it's very similar. Let's say we are going to be writing a smart contract that will issue reward tokens to stakers. So let's say we deploy a smart contract and issue our Aptos token, then we will have another smart contract that will provide rewards, a reward pool smart contract. That smart contract must query, for example, this is just hypothetical, it's going to be calling that token smart contract and is going to be obtaining the balance of the wallet that is interacting with the rewards pool, which means what? I can make the interaction between smart contracts, which will be public interactions, I can define those functions to be friend. That means that unless I specify who is allowed to talk to this function, the function interaction will happen. Else, it's not going to happen. I can be restrictive to who can make calls to that function. And let's say my function in the token smart contract allows users to get token balances based on their signer address or account. And I will be invoking that function from another smart contract. I will be doing a call to another smart contract. So I will be using the same smart contract call or function to obtain balances. And then I can pass those return values to another smart contract to do something else. I can define this function to be friend, and I can control who can make calls into that function, which is kind of a big deal from a security perspective, because now I can be restrictive to who can make calls into that function. Well, let's continue. Now let's talk about a very important topic, structs. How do we store data in an Aptos smart contract? Very interesting. When we write structs in an Aptos module, we are going to be defining the struct type. So we have different types. For example, we have a struct that it's defined as store. This struct is going to be storing data. That's why it's defined as store. But we have other structs that could be defined as key. So when we define a struct as key, we are saying that we are going to be indexing references to the global storage based on a key. It could be the wallet of whoever is making the call to store data. So let's say I have one wallet, I call that function and pass some arguments. And from those arguments, I am passing a string value. That struct can obtain the values and then point those values to another struct that is going to store those values. There's one struct that is in charge of indexing the data. There's another struct that is in charge actually storing the data. We access that data. Listen to me carefully. We access that data by calling the key struct, or the struct that has key, then provide the key value, which will be my address, the signer that made the call to that struct. Then from there, I will be invoking the element which points to another struct. In this case, I have a struct defined as user, has key. Key will be my address. My address will be used to index the data. So then we can find the data based on wallet addresses or account addresses. Then that data will be used to reference to the pointer of the info struct that has store. Store has the value that will be storing in that particular smart contract. It's very straightforward. You have a struct that points or indexes data based on a key element. Then we have another struct that stores data based on the element or referenced to the key element that was provided before. Very clever. Alrighty, let's write our first Aptos smart contract module. Then we point to the wallet owner of the smart contract, the wallet that is going to deploy the smart contract. Now we are going to name the smart contract Aptos demo. Okay, first thing I gotta do, I gotta import the libraries that I need. Use std. And now we are going to be importing string, because what we want to do is we want to store a string value in the struct. So we're going to type string. And from string, we are going to import string uppercase. We are also going to be importing from std debug. Okay, you are going to see what we want to do is we want to store that string value, and we want to show that string value when we execute the function using the Aptos TypeScript SDK. And finally, we are going to import the signer because we want to interact with the wallet or the account that is going to be performing the calls to those functions. Beautiful. Now let's write first the struct that is going to store the string values that we are going to be passing and storing those values using the referenced signer account. Okay. Struct info has store. Okay. We are storing data in this particular struct value, and we will pass string as the type. Okay. Awesome. The next struct that I got to type struct, this will be the user, has key. The key is going to be the value that we will reference as the pointer to the info storage for that user account, okay? And we are just going to pass info. We are going to be wrapping all the information that I gotta provide to the struct as the object and pass those values referencing the key. So now I am indexing the data based on user accounts. I will be storing two constants in the global scope of the contract. The first constant is going to be an ID that I want to verify that the user is giving me that ID and allow or deny the user to execute that function. It's to assert that the user is providing the right ID, and we will allow the user to store the username in the contract. Here's the thing. We are going to be storing usernames in string format and reference those usernames to account IDs. And this will be the signer address or the account of the signer, whoever is performing the call in that function. Okay. So the first thing I want to do, I want to provide an ID that I must pass as the argument in order for me to store that username in the smart contract. This is for me to show you how can we do assert and validate that the arguments that have been provided are correct. Else, we can generate an error log that we can see when the transaction has been executed, and we will know where a possible function execution issue might be. Let's do that. Constant. The first one is going to be called ID, and this ID will be unsigned integer 64. Then we will say equals, and we will just make sure that the user is passing that ID in order for the user to store data in this smart contract. Very simple explanation, but I will show you on the next video a more advanced application of this particular scenario. Let's continue. Constant. Now the next one is going to be an error code that we will show in case the function is not executed correctly. Okay, let's do it. So we are going to say constant E as an error, not correct. Okay, which means that it's not correct. I am going to stop that function from executing, and I'm going to generate an error code 1 that I would know the reason why this error got triggered. And this also has to be unsigned integer 64. Beautiful. Let's continue. Now let's write the first function. The first function will allow the user to store the username as a string and reference that username in storage, pointing to the account address of the signer, in this case, the wallet of the user. We will type public entry because we are going to be passing some arguments externally. I have to now type function, and we will say store user. First argument that I'm going to be passing or providing is going to be account, and this account type is going to be signer. Okay. The second argument that I need to provide will be the ID, and we just have to make sure that the ID that the user is passing is 1111. Let's just test and assert scenario. ID, and we will say this is U64. And finally, the value of that user account or user ID as a string. This will be the username. Beautiful. Okay, now let's write the assert. Okay, now I am going to check for a condition. If the condition doesn't match, trigger the error and log in the transaction. So we are going to say what? ID has to be equal to ID. This one right here, else trigger error not correct. Okay, awesome. This will trigger this error right here. We should be able to see this once we execute this transaction. If everything went well and the user provided the right ID, then we want to obtain the user string value with this argument, user ID, and pass that as an object. So we have to wrap this as an object so then we can store it in the info struct. Okay, and you can see the info struct right here. We have to pass this as the same argument, but it has to be wrapped as an object. So let's say let data equals info value, because we have to mimic exactly the same object. Value is going to be the string value. What's the string value? User ID. Now, one thing that we are going to be working with is going to be the option to pass an action that will allow me to store that data in the struct. Now we are going to be working with a global storage operation. This particular operation is called move-to, and you are going to see that we are going to be working with this during this tutorial series. Move-to allows me to move or pass data onto the struct that we have defined in the smart contract. Okay, account. Okay, what's account? It is the key in the struct of user. That's why we need to pass the key. The first argument in move-to will be account. This will be the signer. That will be the key. Next argument is going to be this object that we just generated passed to the user struct. So we have to type user, and we have to follow the object right here, info. And what are we passing in here? Will be data. This will be the values that we stored, okay? And that's it. That will allow me to pass the username as a string to the struct referenced to the wallet of the signer. If the signer decides to call the smart contract to read the struct, we should be able to pull the information regarding that particular signer because it's pointing to that key element. Next item, we are going to be writing a function that will allow me to read the struct and find that username stored in the struct. We are going to be calling public function, and the only argument that I have to pass is what? It's the signer, okay? Which means that I don't have to pass any external arguments, only the signer, which means that I don't need to type this to be public entry. Now I'm going to say get user, okay? And we are just passing account, and we are going to say signer. Now it's very important because we are going to be fetching data from the struct, from the smart contract. We have to specify that this function is going to acquire a particular struct. In this case, it's going to acquire user. Check this out. And there are certain functions that I will be triggering to perform operations into the contract storage, which in this case, move-to is one of them. The There's another one called borrow. The borrow one is going to get information out of the struct, and this is what we want to display that user account. We are going to say acquires which struct is going to be user. Now we can finally write this function. We are going to be obtaining the username. So we are going to declare this variable username, and we are going to type borrow global, okay? And I'm going to be explaining to you what global and global mute means. Global without mute means that this is only read-only, but mutable not only obtains the data, but it also references the pointer to the struct where that data is located, so I can update the data. So I can borrow the data, but also update that data at the same time. We will see this as we go on this video tutorial. So we are going to say borrow underscore global. Now we have to pass as a vector the user struct. Okay, so we are going to say user, and a vector is an array that allows me to store different types of variables, data. We are going to say user, this will be the struct, and now we need to pass the only argument. It's going to be the key. Now we have to pass that key so that we can locate that data in the smart contract and fetch the details and provide those details back to us. So we're going to say signer, we're going to say address of. Okay, under this particular library, I can call address of and I can pass account. Since this will be the state of the signer when it calls this function, it's going to be stored in account. We will be passing that as an argument, so I can pass it here. And what that's going to do, it's going to retrieve the value of that signer account address. That will be the key, and we should be able to obtain the information inside that struct. Okay, now we pass signer address of account. What do we need to do now? We are going to now invoke info and value. Let's do this, okay? So what am I doing right here? I am passing to the user struct the key of account. From the key of account, I want to obtain the info, which is the info right here that points to another struct called info, which has the stored string value of that user account. And we should be obtaining that username as we pass it, okay? And finally, what I gotta do, I gotta debug that function. I'm going to be passing debug so I can print the value of that username that we stored using the first function to store the user, okay? So we are going to say debug, and now we are going to invoke print, and we are going to say what? Username. There we go. And that's it, okay? Once we are done, this is our first simple Aptos move smart contract. I now have to save this. I have to compile it and publish. Then we can write and read the contract. Let's do that. Aptos move compile. There we go. We have compiled the smart contract successfully, and we can see right here, this is the owner account address, okay? This will be the wallet or the account in the Aptos blockchain that will be deploying this smart contract. That will be the owner of the smart contract. And finally, we will pass the name. This will be the name of the module or the contract, which means that I can deploy many contracts under the same address, which is referenced to the owner wallet, okay? Which is kind of cool. Now I'm going to clear, and we will deploy this to the Aptos blockchain. So what I have to type, Aptos move publish. And it's asking me, do I want to submit the transaction? I'm going to say yes. Boom! We have successfully deployed our first smart contract in the Aptos blockchain. You saw it, you saw it, you saw it. We all can learn if we put our minds and our efforts to it. We are done with video number 1. On the second video, my focus is showing you how can we build an Aptos development environment. We are going to be setting up an Aptos development environment in which we can write the smart contract that I showed you, and we are going to be deploying the smart contract, and we're also going to start working with the TypeScript SDK framework for Aptos. So then we can start making calls into that smart contract to read and write. Alrighty, that's it for this video. I hope that you enjoyed this tutorial. And if you do, give me a thumbs up. Subscribe if you haven't subscribed to. Hey, and we'll see you on the next video. Bye.